Okay, problem 3 asks us to give the coordinates ordered pair for point Z. Point Z is down here, and identify the location of this point. Gives us several choices: quadrant 1, 2, 3, or 4, the x-axis, the y-axis, or the origin. So in order to give the ordered pair for point Z, we need to start at the origin. We need our x-coordinate first because x always comes before y in our ordered pair. So to get the x-coordinate, we have to decide how far we have to check how far do we need to go to the right or left. So we're going to the right 1, 2, 3, 4, 5, 6, 7 spaces, and that's the positive direction for x to the right, so that's positive 7. And then we need to go down 1, 2, 3, 4, 5 spaces. Down would be negative for y, so 7, negative 5. Now to get the location, we need to name our quadrants again. Make a C for Colby. You start in quadrant 1 when you start your C. You pass through quadrant 2, then you pass through quadrant 3, and your C ends in quadrant 4. And you can see that quadrant 4 is the location of point Z, so Q4. Problem 4 asks us to move point Z left 7 spaces and up 5 spaces. Let's do that first. Left 7, so 1, 2, 3, 4, 5, 6, 7. That puts us on the y-axis. And then if we move up 5 spaces, 1, 2, 3, 4, 5, that puts us right at the origin. The origin, the coordinates of the origin are 0, 0, and that's its new location. Problem 5 asks us to place point J anywhere on the x-axis and place point K anywhere on the y-axis. Give the coordinates, the ordered pair for points J and K. Let's put J right here. Label it. Okay, starting at the origin, I need to go right 1, 2, 3, 4 spaces. So that's the positive direction, so that's positive 4. And then I don't go up or down at all, so the y-coordinate is 0. Your y-coordinate will always be 0 for any point on the x-axis. Let's put point K right there on the y-axis. And I start at the origin and check my x-coordinate. I don't need to go right or left at all. So the x-coordinate is 0, and that will be true of any point on the y-axis. But we do need to go down 1, 2, 3, 4, 5, 6, 7, and that's the negative direction for y, so 0, negative 7. Problem 6. Which description shows the relationship between the value of a term and n, its position in the sequence? The n numbers, the position numbers, are in the top row. The terms are in the bottom row. We're trying to find the rule that works to get from any n to the term. So there are two ways to do this. The first way would just be to build up the rule on our own, see how this is changing, to see whether it's an arithmetic sequence. If I'm going from negative 3 to 0, that's plus 3. From 0 to 3, that's plus 3. 3 to 6 is also plus 3. And 6 to 9 is plus 3. So we do have an arithmetic sequence, and we said that anytime we have an arithmetic sequence, we can take the amount that the amount that consecutive terms are changing by, and start our rule with that amount times n. Then we check it to see whether that's all we need to do or whether we need to add or subtract something from that. So for n equals 1, 3n equals 3 times 1, or 3. But our term does not equal 3, it equals negative 3. So what do you have to do to 3 to get negative 3? Think about a number line. If you're at 3 and you want to get to negative 3, you have to go 6 to the left, so that's minus 6. So we do that to our rule also, 3n minus 6. Then we have to check it with one other value of n at least, 3n minus 6. If n was 2, that would be 3 times 2 minus 6. 3 times 2 is 6, minus 6 is 0, so that checks out. So the rule would be, looking at these answer choices, multiply n by 3 and then subtract 6. That's the one that will work. One other strategy you could use for a problem like this, since they give you 4 answer choices, you could try all of these with different values of n. If I try subtracting 4 from n, when n equals 1, that does give me negative 3. But when n equals 2, if I subtract 4, that should be negative 2, and it's not. Add 3 to n. If I add 3 to 1, that gives me 4, not negative 3, so that doesn't work. Multiply n by negative 3. Again, that works for positive 1, but it doesn't work for positive 2 because this would be negative 6 if that were the case. So definitely answer choice D. Okay, we'll pick up the review with problem 7 on the next video.